Why are Quaternions crucial for singularity-free robot kinematics? Imagine trying to turn a steering wheel and suddenly hitting a point where your controls stop responding smoothly. That's similar to what happens in robot movement when singularities occur. In robot kinematics, understanding how robots rotate and move without hitting these problematic spots is key. Quaternions play a big role here. They are a way to describe rotations in three-dimensional space, using for numbers instead of the typical 3 or 9 used in other methods. This makes them more efficient and less prone to errors. When robots move, especially in complex tasks like assembly or welding, they need to change orientation smoothly. Traditional methods like Euler angles can cause issues called gimbal lock, where two rotation axes align and cause a loss of a degree of freedom. This can make the robot's movements unpredictable or unstable. Quaternions avoid this problem because they representing rotations in a way that is continuous and free from these singularities. This means the robot can change its orientation smoothly without sudden jerks or control issues. Another reason Quaternions are so useful is that they keep the rotation axes orthogonal and normalized. This means the axes stay perpendicular and consistent during movement, which is vital for accurate calculations. Plus, Quaternions use only for parameters to describe a rotation, instead of 9 in a rotation matrix. This makes calculations faster and more stable, especially when the robot needs to perform many movements quickly. In inverse kinematics, which is figuring out how to move the robot's joints to reach a specific position and orientation, Quaternions help avoid the singularities that can cause the calculations to break down. When combined with dual Quaternions, which also include translation, they make it easier to plan smooth, continuous motions that don't get stuck or produce erratic behavior. This is especially important in tasks that requiring precise control, like assembling tiny parts or performing delicate surgeries. Using Quaternions also helps reduce sudden spikes in acceleration and torque that can happen near singular positions. This means the robot's mechanical parts experience less stress, and the overall movement becomes more stable and predictable. For engineers designing robots, this translates into more reliable operation, fewer errors, and smoother motion paths. In practical terms, adopting Quaternions in robot design allows for better control algorithms, especially in complex environments. Robots can transition through all possible orientations without hitting mathematical dead ends. This makes them more versatile and capable of handling intricate tasks with ease. Whether it's a robotic arm assembling electronics or a drone adjusting its orientation mid-flight, Quaternions help keep everything running smoothly. So, in the world of robotics engineering and development, Quaternions are essential tools. They provide a way to describe rotations that is both efficient and free from the pitfalls of singularities. This ensures robots can move confidently, accurately, and reliably through any orientation, making them a cornerstone of modern robot kinematics.